Modern society runs on a continuous data flow. Global supply chains and high-speed networks coordinate millions of moving parts across the planet every single second. This entire structure is built on a microscopic physical foundation. The semiconductor is the linchpin for all modern digital logic and memory. If we removed every semiconductor from existence, that digital logic would cease to function. The immediate casualties are quantifiable. Microprocessors and memory chips vanish. Diodes and integrated circuits disappear. Every piece of LED lighting and every solar cell stops working. Stripping away this technology does more than change our consumer habits. It leaves us to manage a 21st century world using the mechanical and analog tools of the late 1950s. Without semiconductors, high-speed data transmission is impractical. Because modems require microchips to translate digital signals over long distances, the modern internet evaporates. The collapse extends into orbit. Satellites require microprocessors for communications and positioning. Without them, global networks and GPS go dark. Banking reverts to manual processes. Digital accounts and e-commerce disappear. Every transaction moved as fast as a physical paper trail. Without high-speed links or satellite data, international business and remote collaboration are drastically curtailed. The globalized economy fragments. To maintain basic electronics, we have to return to the technology used before the transistor: vacuum tubes and electromechanical relays. These components are physically demanding. They rely on glowing metal filaments and mechanical switches that are bulky, consume massive amounts of power, and generate intense heat. Because glass tubes cannot be easily miniaturized, computers occupy entire rooms. These machines are restricted to specialized tasks in government labs or large corporations. This chart shows how the exponential growth of computing power, driven by the ability to pack millions of transistors onto a single chip, effectively stops. With vacuum tubes, there is no path to cheap personal computing. This forces the office out of the digital cloud and back onto physical desks. Communication is limited to paper memos, typewriters, and metal filing cabinets. Information processing is no longer a ubiquitous invisible utility. It becomes a slow and highly centralized, labor-intensive task. Transportation undergoes a similar regression. Vehicles run on purely mechanical systems. Cars function without electronic fuel injection, safety sensors, or engine management computers. Healthcare suffers the loss of digital diagnostics. Advanced imaging, such as MRI scanners and CT systems, cannot function without semiconductor-based sensors and processors. Medical practice reverts to clinical observation and manual testing. Life in this world would still be functional. We would have electricity, analog television, and broadcast radio, all powered by older tube-based electronics. Communities become more local and physically rooted. Culture spreads slowly through broadcast signals and physical media rather than instant global streams. This regression would eliminate many modern digital problems. There is no social media addiction, no digital misinformation, and no constant screen obsession. However, that quiet comes at the cost of global knowledge. Remote or poorer regions are cut off from the education and collaboration tools that the internet currently provides. Without semiconductors, the defining features of modern life, instant communication and pocket-sized computing, simply never appear. The world remains an extended mid-20th century, functional but far smaller in possibility.